Today we are going to look at the asymptotes of a curve, and here is a question regarding that. Find the equations for the asymptotes of the given curve. So a curve has been given to us and we have been asked to find the equations for the asymptotes of that curve. So the curve is y is equal to x square minus 7x plus 8 over x square minus 5x plus 6, and we have to find the asymptotes, the equations of asymptotes. So there are two kinds of asymptotes. One is horizontal asymptotes and the second one is vertical asymptotes. And vertical asymptotes, as the name suggests that they are vertical. They will be vertical lines, and we know that the vertical lines, when we write equations of vertical lines, they are written in terms of x, meaning that the equations of vertical lines are x is equal to something. X is equal to 2, 3, minus 2, minus 5, etc. Just like y-axis, because y-axis is a vertical line, and on that whole vertical line x doesn't change. X is 0 and the value of y changes. Similarly, as these vertical asymptotes are vertical lines, their equation will be in terms of x. X will be same on the entire line, but the value of y will change. So we know that it will be x is equal to some value. And what is meant by asymptote? So what do we mean by asymptotes or vertical asymptotes of this curve? So basically, vertical asymptotes, we say that these are the values of x at which the function, not the function, the curve is undefined. As I have written here, curve is undefined at that value of x. The curve approaches that line but never touches it. It will go as close to that vertical line as possible, but it won't touch that vertical line. And as the curve is not equal to, does not have the value for that particular value of x, it would be undefined for that value of x. And in order for this function, this curve, which is which has been given here, y is equal to x square minus 7x plus 8 over x square minus 5x plus 6, in order for this to be undefined, the denominator must be 0, which is x square minus 5x plus 6. And for this to be 0, we will say that for this curve to be undefined, its denominator must be 0. And for vertical asymptote, the denominator will be equal to 0. So x square minus 5x plus 6 is equal to 0. We will break the middle term, which is minus 5x. So we have to look for two terms which will solve to give us minus 5x, and when we multiply those terms, it must give us 6x square, because the first and the last term multiply to give us 6x square. So minus 3x and minus 2x would be those terms. They give us minus 5x on solving and give us 6x square on multiplication. So we'll take common from first two terms, which is x. So when we take x common from first two terms, we are left with x minus 3. And similarly, when we take minus 2 common from the last two terms, we are left with x minus 3. So now we can take x minus 3 common from both terms and we are left with x minus 2. So these are the two factors, and we basically want the equations for the asymptotes or vertical asymptotes, we basically need those values of x for which this function is undefined. So we will put these values equal to 0, these factors equal to 0. So x minus 3, we will put x minus 3 equal to 0, and we will put x minus 2 equal to 0. So we will get x is equal to 3 and x equal to 2. So these are the two values of x, or two vertical lines which our curve will never touch. It will approach these two vertical lines, but it will never touch these two lines. So these are the vertical asymptotes. For horizontal asymptotes, obviously there will be horizontal lines, and if there are horizontal lines, they can be written in terms of y. They will have equations y equal to something, 2, 4, 1, whatever. Because in horizontal lines, the values of x changes, but the value of y remains same, just like x-axis. So how do we define horizontal asymptote? We define horizontal asymptotes as the value of y which the curve approaches when x approaches infinity, negative infinity or positive infinity. So meaning the value of y which is approached by this curve when x is very large or very small, because positive infinity means a very large positive number and negative infinity means a very large or a very small number. We can say a very small number, because whenever numbers increase in negative direction, they become smaller. So we want to find the value of y of this curve, or the value of y which this curve approaches when x becomes very large in positive direction or x becomes very large in negative direction. So firstly we'll see for the positive direction, for positive infinity, or for a very large positive number. So this is a quadratic, we have a quadratic quotient here, and quadratic expressions are written in both numerator and denominator. So firstly we'll check it for a very large positive number, and let's consider x is equal to 100. When we put 100 in numerator, it becomes 100 square, which is 10,000, minus 7 into 100, which is minus 700, plus 8. We can see that when we put a very large positive number in this numerator, the answer of quadratic term dominates or matters much more as compared to the other two terms. The answer of quadratic term when we take x is equal to 100 is 10,000 as compared to minus 7x, which is minus 700, which is much smaller than 10,000. And similarly 8 doesn't have that much impact either. So what do we observe here? That whenever the number is very large and it's a positive number, it's a very large positive number, the quadratic term dominates. We can ignore the other two terms. Maybe not in 100 case. It was just for it was just to give you an example, but the idea is that as positive infinity is a large number, very large number, it's not equal to infinity is a relative term, but this was just an example. It was just to give you an idea that as the x gets larger and larger in positive direction, the terms minus 7x and 8 don't matter that much. So x square dominates. Same is the case in denominator. So we are left with y is equal to x square over x square, and because x square and x square are same, whatever positive value we put in x square and x square, because the terms are same, they will give same answer and they will cancel each other to give us y equal to 1. So the horizontal asymptote will be y equal to 1 for a very large positive value. For a very small number, or we can say for a large negative number, it will be same. The value of y will be same, or the horizontal asymptote will be y equal to 1, because firstly the expression is same. So when we put negative number in this expression, because it is getting squared, it will have same answer for this quadratic term x square in both numerator and denominator. And minus 7x plus 8 and minus 5x plus 6, we can ignore those terms in both numerator and denominator. So we'll be left with the same one, because the terms that matter in both numerator and denominator, in case of negative numbers also, in case of negative numbers, very small numbers also, it will be x square and x square. And because the values of x are being squared, the answer will be same as in the case of very large positive numbers. So x square and x square will be cancelled, and we will be left with y is equal to 1, and this will be our horizontal asymptote. The value of curve will never be equal to 1. This will be that horizontal line which will be approached by this curve, but that curve will never be able to touch it. So these are the two ideas, vertical asymptotes and horizontal asymptotes. Vertical asymptotes simply is the value of x at which the function becomes undefined. The function can't reach it, can't touch that line, it just approaches it. And the horizontal asymptote is that horizontal line, or the value of y which is approached by the curve but never reached by it, whenever the x becomes very large or very small, or x approaches infinity or approaches negative infinity.